Well, we can question what's
But then
Depends on the make, then, and it's maybe which is better, Samsung or Sony.
But if you can use those devices, that's great. But I think it's very easy to compare and see can we compare the values that we get. And my conclusion after this test was that no, I cannot use it.
Okay, but we have also some external sensors, so it's not a problem. Just the question is that it has to be this one, or we can put our own, which
Joachim found a pretty good sensor, which is rather expensive. But then, I mean, as I was explaining, and now we'll see what is the actual test and what are the data acquired. We are measuring within 100th of a degree an angle that is varying by plus and minus 1 degree. You know, and then our safety is only to take a big number of measurements and then average them out. This is,
I think it's not so much question of if you are going to 0, 1 degree or 0, 1 degree. It's not a question of precision. It's a question of taking time, because this is not a measurement. This is not a measurement. If you have to measure distance from here that is fixed, then you measure that's the distance from here. And this is the measurement that includes time, because the whole thing is moving. But it's not that you are measuring here. If we put the sensor here now on this table and leave it like this, we will measure the angle, you know. But if this is moving, we need to measure the time. And you know, you probably may, and there has been someone was found that okay, you know, not the phone, but inclinometer with precision of 0.01 degree for $300, you know, on the internet, and then you still need how to use it.
Of course.
I mean, the advantage of this is both hardware and software. The software that is customized exactly for what we need in ORC. And this is the only one. Probably some other can also do the same.
Yeah, well, but then I think that the validation, like Johan was saying, is necessary to check, because also the smartphones may use themselves different sensors.
Yes.
And then there is the iPhone and there is Samsung.
I think again, it's not a question of accuracy, how you can accurately measure fixed angle. It's a question how you accurately can measure something that is moving during time.
And how much sensitivity is to humidity, temperature,
and all.
if there is a let's say a systematic error, or if this error is random.
You know, it's I can tell you that we have 3 measurers who are having this in Croatia, and I would say I was very lucky, because at some point of time in the federation there was some money to spend, you know. But now when I get the opportunity, I said, okay, let's buy 3, give it for one I'm doing on the north, one on the middle Adriatic, one on the south. And then when we are doing, I'm sure that at least the level is the same. So otherwise, if you have this device, it really depends on the good measure.
Yeah, it's true.
You know, it really, I mean, device is device, and it works but you need to have the measurer who can concentrate and exactly read what is happening.
Also depends on the conditions.
Exactly. So, and then when you have the same tool for everyone, then it's much easier. And then I will always prefer not to advertise Joachim, but I know that this is working and it's good. And everything else, yes.
What accuracy of the angle do you require?
Yeah, that's what we said. We are measuring 3 to 4 angles on one side. The electronic one has 0.01 angle accuracy. One 100. Yes. But as I said,
which is this was a requirement, because assuming you can read 2 millimeters on 2 meters,
it's
on the manual one,
which is the same, you know.
Yeah.
Because for the manual one, the minimal distance here should be 2 meters. And then if you read 2 millimeters here, this is,
Yeah, one of tens of
Yeah.
of degree.
Yeah.
Yeah.
But,
This should be enough, yes?
yes.
Okay.
But it's, again, it is more the question how this electronic or any measurement is accurate during the time while boat is moving. Because boat is never can be completely straight. And then we didn't do this, but there is also another possibility, particularly for the big boats, to do inclining with the boom. Instead of setting up the pole, because for the big boats, the pole should be quite long and the weight should be quite low. You do in a way that you put the boom outside, and the end of the boom should stay on the same LCF position where the poles would be. And then first you measure the boat with the boom only. Because of the boom only, boat will be heeled for some half degrees or some. And then you measure without weight and you measure with weight. So you have 4 weights, 4 readings for 1 minute without, 4 readings with the weights on one side, and then you repeat on the other side. The only problem at this is that you need to find to measure the weight distance, as you have only boom on the one side. You need to find the center line of the boat, and to find the center line of the boat, which is somewhere in the air, you need a string that you will put in the somewhere in the mast in the center line, and hopefully if you have the backstay, single backstay, you go to the backstay and you put a string that is defined your center line. If you have a double backstay or backstay that goes like this, then you have to find a way how to find the still center line on the boat. And frankly, with the last time when we did the